Hello folks, welcome to another super boring barn update video where you are going to see me fail dreadfully at attempting to get the onboard charger from a MG ZS electric vehicle working on the bench. In this no, it's not really semi-exciting, is it? It's boring episode. I'll go through what I've done so far and my testing setup here and why I think that we are not having success with this charger. Now, why am I looking at chargers so much? Well, some of you may recall that last year I'd been looking quite heavily at a series of Volkswagen or VW chargers. And yes, we can make them work. And they're quite good, like they're very compact, powerful, do a lot of stuff for us, but they're extremely finicky and need quite a lot of coaxing to bring them to life, involving particular diagnostic programs to reprogram them and switch off various functions and all this kind of thing. So I've been casting around to try and find a reasonably powerful, so like 6.5 kilowatts minimum, reasonably small, and above all cheap and easy to find onboard charger that we can hack so that folks can use it in EV conversion projects. Now, not least of which that I have, as you will know, several vehicles undergoing conversion at the minute here, and having a good, reasonably powerful onboard charger that's not a Tesla charger, let's say, would be a nice touch. So I was casting around and I came upon the MG ZS charger. It's 6.5 kilowatts, and I believe the later versions, so like from 2021 up to present day, have actually got V2L capability on them. And what that means is that they can put out AC power as well. I guess the voltage and so on depends on your jurisdiction. Here it would be 230 volts AC 50 hertz. So you could, they'll work basically in both directions. So I think the one I have here is my 2019 vehicle, so it does not have that V2L capability in it. But we are and have been working on this now for, I guess, around 3 months, maybe longer. Time flies. This charger I picked up for 150 euros, and I think they're kind of in or about that price bracket, sometimes a little more, sometimes a little less. I'll put a picture up of the info plate on the charger that I have here, so that you can, take down the information from it and see what it is. Now, this isn't going to be one of these videos where I desperately request CAN logs, because thanks to some very helpful folks, I actually have 2 sets of CAN logs from 2 different MG ZS vehicles. So I think we're pretty good on CAN logs. Unfortunately, our charger isn't just not responding. As Jack Rickard used to say, it's the electronic laser. You plug it in, switch it on, and it just lays there, which is exactly what our charger has been doing since day one for me. But as Jack also used to say, it's head, wall, wall, head. It's gonna hurt, and it's hurting, but we'll get through the wall. So there are 2 signal wires, and I'll describe them in another segment here. And I don't know what they do. So I suspect, could be totally wrong, I suspect that the reason our charger is not merrily bursting into life and making me look really cool is that I don't have a particular sequence, a particular signal, a voltage level, whatever it may be, on at least one, if not both, of those signal lines. So folks, what I am requesting a little bit of assistance with is if anyone that has one of these vehicles available would be so good as to stick a multimeter on those two wires for me before, beginning, during and after charging, and we try and figure out what those signals are supposed to be. That would be most helpful. Also, while I do have CAN logs, what I don't have is much or indeed any information about the makeup of the CAN messages. So if anyone has DBC files or info on the makeup of in this vehicle, the names of the CAN buses change depending on which page of the wiring diagram that you're on. But the most consistent names are the local CAN and the diagnostic CAN, as they connect to the signal connector on the front of our charger, which we'll be having a look at. So if you have any information on those CAN networks, please do let me know, because we are kind of flying blind at the minute here, just kind of hoping we can stimulate some kind of response from the system. So let's go ahead and we'll have a look at a failed attempt to get the charger to start up. We'll look then at the signals at those that low voltage connector, and I'll describe what I know about those signals and the ones that I do not. So now would be the time, or preferably before now, to press the stop button, press the dislike, go up there, type funny cats, and get yourself the hell out of here. Alrighty folks, let's have a look at our testing setup here. Apologies, I know the sound isn't going to be brilliant in this particular segment because I'm just using the built-in mic in the phone. I know I need one of those, cool kind of Rode microphones here now that all the cool kids have. Anyway, so what we have are two computers. You can only see one. This one here is set up with an Arduino DUI to play back the local CAN messages, and I have my desktop computer here just out of shot that will play back the diagnostic CAN messages. We have mains power connected. Just got it on a 13 amp plug here at the minute, so I can turn that on and off manually. The charge port temperature sensors currently have a couple of 100k resistors in there, which is giving me a value on the CAN feedback as close to what's in the logs as I can see. Now, the last folks that actually did logs for me actually measured the resistance, and I believe at an ambient of about the high 30 degrees, 37, 38 centigrade ambient, they were about 69, 70k, something like that. So I think they're close enough to get us, so that that's not going to be the thing that causes us problems. Our two mystery signals here, I'm just leaving them disconnected. I don't know what to do with them. What else is there? High voltage has been provided outside by the Lanyard's CHAdeMO port, coming through our trusty 100 watt filament lamp here. So what I'm going to do is I'm going to turn on the low voltage. I'm going to turn on the high voltage. We'll start sending CAN, and ultimately nothing's going to happen. But yeah, at least it'll be kind of showing you where we're kind of at with this and what the testing setup currently is. Don't worry, I'll cut this bit out where I look like a prat. Wait a minute. I'll have to cut all of it out. Alright, you can see me look like a prat. I could start sending a can, that would wake it up, but let's try not to do that. I could sing a song, do it a dance. Anyway, let's try again. Yay, we're on. Okay, so let's go high voltage on. We will commence sending diagnostic can here, sending here, and we want to go AC on. And when we go AC on, we jump up on our 12 volt system to around 470 milliamps of draw. But ultimately what's going to happen here now is that our charger is basically going to ignore us. It won't do anything. It's just going to sit here until the can log to run dry. And at that point it'll turn itself back off again. So really exciting. Okay, let's take a little bit of a closer look here at our charger connections. So on the left we have our high voltage DC. On the right we have our AC single phase 230 volts. In the middle is where we have our signal connector, and this is where I suspect that my problems are in terms of getting this charger to work for me. So going from the top left over to the bottom right, I won't show you a diagram or that because the wiring diagrams for this car are terrible, honestly, and the naming thing changes depending which page that you're on. So I'll do my best to kind of describe these. 12 volts positive, top left, then we have our 12 volts ground. Now then we have the first CAN bus. This is what's called in most parts of the wiring diagram local CAN. Next beside that then is the second CAN bus. Whoops, and it's wrapped around the leg of the tripod. And this is usually called diagnostic CAN. Now, what I've discovered so far about these two CAN buses is, starting with the diagnostic CAN. The diagnostic CAN is not terminated inside the charger. On application of power, it neither sends nor receives any messages. If the charger is asleep, sending messages on this bus will not wake it. I suspect this CAN bus may need or may respond to certain IDs for diagnostic purposes. So like this, what is it called, ISO-TP method. So that's one way that we could possibly look to interrogate the charger to see what's ailing it. Now, coming back over to the local CAN. On power up, so just applying 12 volts power, this CAN sends 1, 2, 3, 4, 5 IDs. 3B8, 3BA, 3BC, 3BD and 3BE, all at 100 millisecond intervals. They contain information about things like the charger voltages, currents, AC, DC and stuff like that. Now sadly, we don't have any DBC files available for this vehicle or this charger, so all I can really work out from those IDs are things that I can cause the charger to respond to. So things like the charge port temperature sensors, AC voltage, DC voltage, and kind of working out from the logs what actually is being said. Now, let's turn that power supply off for a sec. So, if the charger is asleep, sending any CAN ID at almost any speed on local CAN will cause the charger to wake. From the logs that I have, the only ID apart from the 5 that seems to be on that bus is 29C. And that seems, by just looking at it in the SavvyCAN graphing functions, to be sending power requests and things like that, because there's these kind of ramping things that you can see in it and stuff like that. Now, that's our top row. Now, working our way along the bottom row, now the first of our charge port temperature sensors here on the bottom left. Then we have this red wire here, so the second from the left on the bottom row. This is referred to in various names. I've picked one of them here, which is wake up. If our charger is asleep, I have attempted to do things like ground this, apply 12 volts to it, via resistors, whatever else, nothing. It just ignores it. It won't do anything. So whatever signal that this is the first one that I've no idea about. Moving along then, we've our second charge port temperature sensor. And second last from the right on the bottom row, we've our next signal that I don't know about. Best name I can find in the diagrams is called Connect Confirm. Now this one I suspect is quite important. It does not output anything regardless of what the CAN logs are doing. No matter how I stimulate this, and I have to be kind of safe and use resistors, I cannot get the CAN that is being sent from the charger to respond to any signal that I can generate on either of these two wires. Now that could be simply that they're not reflected in the CAN IDs that I can see at the minute, or simply that they're complete red herrings and they actually do nothing. Now I don't think they do nothing because this Connect Confirm is connected to the high voltage battery in the vehicle, as is this wake up. So both of these do connect to the BMS in our MG ZS battery, and they're not there for no reason, I would suspect. Finally, bottom right, we've our common wire for our charge port temperature sensors. So that's where things stand, folks, in terms of our wiring connectors here. So what I've been doing over the weeks and months is basically just trying combinations of playback of the CAN logs, applying AC and DC various different times, and seeing if I can really just get the charger to do anything. And it is determined to do the same thing all the time, which kind of leads me to believe that, yeah, one of these guys is, or both of these guys could potentially be where our problems lie. So just a very quick little look here. This is what we typically see on our local CAN. The bottom 5 IDs starting with a 3 all come from the charger, and the 29C there up on the top, I imagine that's coming from our BMS. I also think that this charger should be fairly simple. I mean, it's I wouldn't be at all surprised if it finds out that, you know, ultimately that we really only need one CAN ID to run this thing, and that being 29C, and that the reason it's steadfastly ignoring me is just down to those analog, we'll call them, signals. Because again, this is, I've had a few logs now. I think I've had 2 logs from 2 different vehicles. And this is very consistent, and the data in this 29C and these other 3 messages here is very consistent. So yeah, that's about where we're at. And again, I never see any IDs coming from the diagnostic can, regardless of what I do with the charger. Okay, welcome to the test bench. Right here in the middle of this mess, you can see I have quite a few chargers. I have a Volkswagen charger, a BMW charger, and in the middle here is our MG charger. You'll see on the back, as soon as my tripod decides to play nice, see on the back with our water cooling ports. If we tour over the top of it here, we'll see our information sticker there, which hopefully you'll be able to pause and have a look at. This is actually quite a nice compact charger. As I say, it's about 6.5 kilowatts, and it's I guess it's about the size of an old telephone directory, about the same weight as well, but it's got some quite easy mountings on it. See there on the right and the left, so there's not a whole pile of fabrication that would be needed to get this thing to operate. So might as well, seeing as we're here, pop the cover off. Yes, let's pop the cover off by not taking the screws out, genius. Not that I'm done embarrassing myself on this particular video, but okay, let's pop the lid off now. So, in here, we can see we have a lot of these silicon pads on top of the magnetics. They're for transferring the heat out of the things like the transformers into this heatsinky type lid component here. Now you'll see I've done a few little modifications here. This one was me attempting to bypass the HVIL for this AC connector here, because I don't have the plug, the AC connector plug, I guess, that would be going to the charger socket. So I've just basically bypassed this with a resistance here. And the resistors has fallen off. Yay. Well, that'll have been definitely helping the signal integrity. Let's not embarrass myself. I'll cut this part out of the video. So yeah, that's our HVIL. I had been, let's say, experimenting with this, trying to get something to happen. Yeah, no luck so far. As I say, the only response that we get from this charger is when we apply the mains power. You'll hear it click, and I guess it's a pre-charge come on, and then our 12 volt draw increases by about 150 milliamps. Okay, well, let me say that I might have a moderate little bit of excitement for you now. Got a multimeter just on continuity test here. This is our connect confirm wire. I said I had no idea what it does. I still don't, but we've just discovered something. I'm going to take my connect confirm, connect it to one of the multimeter probes. The other multimeter probe, and see we have a little red and a black wire here that were originally going to the high voltage interlock on this AC socket. If we touch our probe onto the red wire, we get a circuit, and our multimeter starts beeping. Now there's no connection on the black one, nor can I find anything if we go to the ground on our charger. Like if we get our charger ground here, this still doesn't give us anything, I believe, to that black wire. Certainly no short circuit. If I just go to resistance, yeah, there's nothing, there's no connection to ground. But that red wire here from the HVIL goes to connect confirm. Okay, so new request. This is an evolving situation. Someone with one of these cars could unplug this charge port AC and measure the DC resistance of the two HVIL pins to see if there may be just a short circuit or there may be some kind of a resistance in there, I'm not sure. And then measure the voltage that's on that connect confirm pin. We would then know what we're supposed to feed to this. Now, it's not at all unreasonable that the charger would refuse to operate if it doesn't have. If this connect confirm is some kind of a high voltage interlock, it's not at all improbable that the charger would refuse to work at all if it thinks that, let's say for example, that either the AC plug here is not fully seated or if the BMS isn't supplying the correct high voltage interlock signal. Now, depends on the vehicle architecture. It may be that the charger couldn't care less about that. It may be something that is solely the purview of the BMS, and I'm wasting my time looking at these two signals. I genuinely don't know. But I'll put up on the GitHub repo, I'll put a link to the repo in the description anyway. I'll put up on the repo the CAN logs and so forth that I have, so folks can kind of play along at home. But I think going to have to do a little bit more investigating. May even be a thing that I have to kind of delve into the guts here. I'm kind of reluctant to do that. It's kind of a last resort for me if I have to start taking things apart in here, because most of the connectors, as you'll have seen, have got all this kind of sealant goo on them. So the probability of me damaging something if I go poking around in there is pretty high. So interestingly, the DC side here does have a high voltage interlock in it, but I don't even need to measure it. You can just see in there that it's literally just a short circuiting pin, which is what these things usually are. Now this one comes up off here, off the side, and goes across this red and black wire over to this part of the board here. Whereas the one from the AC goes to this little auxiliary board here. So I've just taped that up at the minute now, just twisted them together, taped them up in there. I might see, like I said, it's a last resort now. If we don't have any luck getting this charger to work, then as a last resort, I'll kind of dig in here and we'll see if we can find the main processor and see if we can, you know, kind of work out a little bit about how the hardware operates in here. Not really the way I want to be going here, but if it's not going to work, then it's basically scrap anyway, and we may as well learn something from it that way. So folks, again, yeah, a little bit of interest there. I still think with these signals, I don't know if the wake up one has any relevance, but this connect confirm now definitely looks to be doing something. And yeah, any info on that and any info on the CAN would be much appreciated. Okay folks, so we've learned a little bit here during the making of this episode. Might bring us a little bit nearer to some measure of making something happen. So just to repeat again, if folks have any info, particularly on the CAN, the local CAN and the diagnostic CAN, and those two signals, which we now seem to think that the connect confirm has got something to do with the high voltage interlock. And the wake up, again, don't know, maybe important. It may have to be at some level or have some kind of a signal on there before our charger will wake up for us. So I'll leave it there. This video has been sufficiently boring for now. Don't forget to thumbs down, dislike. Oh, also, don't put any comments down here because apparently that will result in PooTube recommending it to more innocent victims. Don't do it. Do have a look at the links in the description for Patreon and PayPal, just so you can avoid financially supporting me, because then I'll waste your money on things like these stupid chargers and fail to make them work. So don't do it. Do check out links for the Open Inverter forum and so on in there. Oh, and I'll put a link to the GitHub repo for what I've learned about the charger so far. Do check out my 1960s era fuse board here. Don't worry, it's not live. I just left it there for nostalgia's sake. And we will then hopefully see you in the next semi-exciting episode where we might actually get this charger to do something. So, until next time, happy signal tracing.